Let's take a look at the one on the left first. Hopefully the first couple steps should be fairly obvious. We subtract 1 from both sides. And then divide by 9. So then it's a matter of determining where tangent equals 1. For what angles does tangent equal 1? Pi over 4. Pi over 4 is our first quadrant solution. We also have a solution in the third quadrant, which would be pi plus pi over 4, which is 5 pi over 4. Here's the problem with this one. In the book, or sometimes on Wiley Plus, it will tell you to find this value for theta in a right triangle. Okay, so theta has to be less than 90 degrees or less than pi over 2. However, if you're given a whole 2 pi rotation, a full rotation of the unit circle, it complicates things. If theta is between 0 and 2 pi, what would be the range or the interval for 5 theta? If the smallest value that theta could be is 0, what's the smallest value that 5 theta could be? 5 theta also can't be any less than 0. But if the largest value for theta is 2 pi, what's the largest possible value for 5 theta? 10 pi. So the problem with those equations, when you have that multiple on there, and we won't do a lot of these, they don't really get addressed much with the book, is that you have to look at 5 full rotations because 5 theta could be so large. And we'll get rid of the 5 here in a second, but you have to take that into account. So you have to look at further rotations up to 5. So, which means if we have 2 solutions in 1 rotation, we're going to have 10 solutions in 5 rotations, and they're coming every pi. So all we have to do is keep adding pi, which is 4 pi over 4. So we'd go to 9 pi over 4 and 13 pi over 4, 17 pi over 4, until we have 10 full solutions. So as you see, wow, that's quite noisy. The solutions become more and more complicated. And then, to simplify it down to theta, we divide both sides by 5, which means we have to divide every one of those solutions by 5, which is the same as multiplying their denominators by 5, or multiplying by 1/5. So we'd have pi over 20. 5 pi over 4 would simplify to just pi over 4. 9 pi over 20. 13 pi over 20, and so on. Now, if you were to graph this in your calculator, if you were to graph on one side 9 tan 5x plus 1, and on the other side, and the second equation, graph 10, you would see all of these intersections between 0 and 2 pi. And they obviously wouldn't be that far apart. Okay, they're only a fifth of a rotation apart. But that's not a bad idea to do when you're approaching this. Graph those two equations in your calculator. Set your x min to be 0, your x max to be 2 pi, and see how many intersections there are. Okay, that will tell you how many solutions you should have. The trap is to stop here and think, okay, I've got 2 solutions. When you graph them out, that will help point out to you that you should be looking for a lot more than 2. Okay, the one on the right, the problem on the right doesn't have that hang up, doesn't have that issue. What we want to do is we want to remember that we have an identity, 1 plus tan squared theta equals secant squared theta. So what I can do is I can replace the left-hand side of the equation and the right-hand side of the equation. I'll leave the right-hand side of the equation as it is. And then it goes back to solving this one just like we solved the one in our notes. You move everything to the left side. This one simplifies a little more than the other one. Because the ones will cancel out, we'll have tan squared theta plus tan theta equals 0. And factoring this is much simpler because we could factor out a tan theta and we're left with tan theta plus 1. So we have solutions when tan theta equals 0 or when tan theta plus 1 equals 0, which is when tan theta equals negative 1. So we know that tan is 0 whenever sine is 0, which is pi over 2 and 3 pi over 2. No, it's not. Yes, it is. It's not. It's not that at all. Sorry, it's when sine is 0, which is 0 and pi. And then tan theta equals negative 1 at our reference angle is pi over 4, but it's negative in the second and fourth quadrants, so we want 3 pi over 4 and 7 pi over 4. Okay? Because we've got this angle here, this angle here, so we're looking for 3 pi over 4 and 7 pi over 4. Again, easy to check by plugging them back into the equation when you're done. Hard to find them just by graphing. You have to really know the algebra that's behind it. But again, all of these steps, besides the substitution, besides the identity substitution there in the first step, the rest of the steps are all basic algebraic steps that you learn in Algebra 1 and Algebra 2. We're just taking them a step further, throwing that identity at the beginning, and then pulling out the angles at the end. Are there any questions before we quit for the day? All right, guys, and I wish you a wonderful Thanksgiving break. I hope you enjoy your time with family and friends. I'm thankful for the opportunity to teach this class, and I hope you'll have a great break.